Hola everybody, Assalamu alaikum warahmatullahi wabarakatuh. We have arrived at chapter 7, Haloalkane, and in lesson 69 we are going to learn about how to synthesize haloalkane. Firstly, we need to know what are the functions of haloalkane in our everyday lives. Then we want to classify primary, secondary and tertiary haloalkanes. We need to describe that haloalkane contains polar bonds, so it is susceptible. It can be attacked nucleophilically. Then we want to learn the reactions to synthesize haloalkanes via 4 reactions. Halogenation of alkene in UV, we have learned this. Hydrohalogenation of alkenes with or without catalyst, also we have learned this. Halogenation of alkenes in CCl4, we have learned this. And finally, substitution of alcohol. This is the only reaction that is new for us in this lesson. When refrigerators and freezers were created back in the 90s, they used ammonia as the gas that distributes cold air inside the machine. It's just that a lot of people died because of the poisoning effect. So starting from 1930s, they tried using chlorofluorocarbons, which are considered to be stable and inert towards human health. It's just that CFCs later was discovered to be toxic to the environment because as it is released to the atmosphere, it will react with the ozone under the presence of UV light, i.e. sunlight. So these are one of the examples of usage for haloalkanes. Haloalkanes or alkyl halides are organic compounds that contains halogen atom as functional group. The halogen atoms will be bonded to an sp3 hybridized carbon atom. The general formula is Rx or CnH2n plus 1x for a cyclic compound or CnH2n minus 1x for cyclic compound, where X is any halogen atom, whether fluorine, chlorine, bromine, or iodine. Haloalkanes are polarized. Why do we say that? Because the halogen atom is more electronegative. The density of electron will be near towards the halogen atom, making the carbon is electropositive and therefore it is an electrophilic site, making it susceptible to nucleophilic attack. Here is more function of haloalkanes as inert substance. CCl4 can be used as solvent. CHCl3 chloroform can be used for solvent in cleaning. CF2Cl2 called Freon 12. It is a propellant in aerosol sprays. CFC is the refrigerant gas in freezers. DDT, dichlorodiphenyl trichloroethane, is an insecticide. Haloalkanes are classified based on the carbon atom to which the halogen is directly attached. For example, if we have here CH3X, X is basically attached to a methyl group, CH3. For RCH2X, X is attached to a primary carbon, so it is called a primary halide. For the third example here, as you can see, the carbon is attached to two carbons, 2R, so it is a secondary carbon. Therefore, we call this compound as secondary halide because the halogen is attached directly to the secondary carbon. Let's look at the fourth compound here. The carbon atom in the middle is attached to 3 Rs, so it is a tertiary carbon, making this compound a tertiary halide because the halogen is bonded to the tertiary carbon. The fifth compound here is called aryl halide because the halogen is bonded to the aromatic ring. But the last compound here, the X is actually attached to a primary carbon. So it is a primary halide, not an aryl halide. Now, let's do practice 7.1 together. Give the IUPAC name and classify the following haloalkanes. For the first one, A, it's the simplest compound we have now that we have done the naming test. This compound is called bromoethane and it is a primary halide. Right? Okay, let's look at B now. B is, as you can see, the carbon number 2 is attached to 1 chlorine. So the name is 2-chloropropane and it is a secondary haloalkane. Next, question number C. Okay, let's redraw this compound. CH3, 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 and Br. Br is attached to the tertiary carbon. So this is a tertiary haloalkane. But what is the name? We have 1 methyl and 1 bromo attached to carbon number 2. So this is 2 bromo, 2 methyl propane. Okay, now let's look at D. Chlorine is attached to the carbon in the middle here. This carbon is basically a tertiary carbon as well. So how do we name this compound? Let's count the carbon starting from here. 1, 2, 3, 4, and we have 2 substituent. So 2-chloro, 2-methylbutane is the name for compound D. What is E? This is a fluorobenzene, simple. What is F? This one is actually an iodomethylbenzene. The common name for this compound is actually benzyl iodide. Lastly, G is 1-chloro, 1-methyl cyclopentane. But what is the type of haloalkane this is? This is a tertiary haloalkane. This one is primary, and this one is an aryl. Okay, I forgot to mention the classification because the naming is too easy. Now let's open your page 263. And then we are going to fill in the 4 boxes on the left side of the mind map. These are the 4 reactions to synthesize haloalkane. 3 of the boxes are the reactions that is already familiar to us since we have learned it in chapter 5. But the last one is new for us. Let's look at it soon. Let's do example 7.1, question number 1. This is a free radical substitution. So there are a lot of places where we can substitute any hydrogen with chlorine. So which one is going to become a major product is the one that will produce a stable free radical, which is tertiary free radical. So basically, the chlorine will be attached to the carbon that is a tertiary carbon. So the answer for this question is, let's draw the whole compound here from left. Chlorine will be attached to this carbon because it is the only tertiary carbon in this compound. For this particular carbon that I am drawing here, it is a quaternary carbon, so it is not available for attachment with chlorine. Therefore, this is our product. Let's name them. This is chlorine at carbon number 2, a substituent and a substituent. How many carbon do you have? 1, 2, 3, 4, 5, 6. This is a hexane. Oh, we have another substituent over here attached to carbon number 4. So this is actually 2-chloro and then 2,4,4-trimethyl-hexane. Voila, this is your answer. If the question doesn't ask you to name the product, you don't actually need to name it. 1 mark for the structure and 1 mark if asked for the naming. Now let's look at the second example. This is basically an electrophilic addition because the reactant here is an alkene. You have a double bond over here. So this reagent is HCl. H is going to be attached to the carbon that has more hydrogen according to Markovnikov rule. Let's look at the restricted carbon over here. This carbon has 1 hydrogen, whereas the second carbon here also, it doesn't have any carbon. Yeah, sorry, it doesn't have any hydrogen, not carbon. So this second carbon will be attached to it, chlorine, because it doesn't have any hydrogen. Since the first carbon here has 1 hydrogen, hydrogen will attach to it. We are following Markovnikov rule. Okay, you have to apply this rule in any reaction that we're going to look at after this. So let's draw the structure. From below, CH3, so CH2, I am already inserting the hydrogen there at carbon number 2, and then I'm drawing a carbon there where I'm going to attach the Cl. Then this is a cyclopropane, cyclopropyl, and then this is the isopropyl part up here. Do you want to name this compound? Yes? Okay. So the name for this compound is, let's name the number, the carbon first. 1, 2, 3, 4, 5. It is a pentane. And then let's circle the substituent. 1, 2, 3. So it is 1 3-chloro, and then 3-cyclopentyl, no, not pentyl, propyl, sorry, propyl. And then another substituent is carbon number 2, 2-methyl, and the parent, that would be 5, is pentane. Okay, so it's 3-chloro, 3-cyclopropyl, 2-methyl pentane. The second question for example 7.2 is using anti-Markovnikov rule because it is using hydrogen peroxide as catalyst. So what we're going to do is firstly draw the cyclopentane, and then I'm going to draw the side chain up here. The double bond would be formed here because bromine would be attached to the carbon that has more hydrogen. This second carbon has more hydrogen compared to the first one here. So the double bond would be formed between this carbon and this carbon. Now we have another bromine over here. We can create a double bond whether here or here because both of this carbon has the same amount of hydrogen. So I choose to put the double bond over here. So this is your product, your reactant for question number 2, example 7.2. Now, straight to example 7.3. Here is a bromine test where we're going to do halogenation on alkene in inert solvent, CCl4. So what we're going to have here is a dibromo compound where we're going to insert both of the bromine atom at that particular carbon which I labeled. So all we have to do here is just copy down the skeletal structure, and we're going to have haloalkane with 2 bromines attached to that particular carbon that is having the restricted carbons double bond. Let's do example 7.4. For this reaction, we are going to do nucleophilic substitution of alcohol. Basically, we're going to learn this reaction again in chapter 8, hydroxy compound. We're going to substitute basically the hydroxy compound here with a chlorine compound over here using a reactant. The reactants are listed in your page 251, where for chlorine we're going to have either PCl3 or PCl5 or thionyl chloride, SOCl2. And we're going to produce either H3PO3, POCl3, or SO2 as the byproduct. Now let's look at the second question. We're going to replace hydroxy group here with a bromine atom there. So all we have to do is just copy down the skeletal structure there, and we're going to replace the OH with Br. So this is the product F. Answer for question number 2, example 7.4. Now, that's the end of lesson 69. Thank you very much for paying your attention to me, and I will see you again soon for the next lesson. Bye. Assalamualaikum.